When the Earth is seen from space, it appears blue. Now, a common misconception is that this is on account of the presence of water on the Earth. However, a closer look reveals that this is indeed not the case. It is the Earth's atmosphere that appears blue, even at places where there is no water beneath it, just plain dry land. This blue color is on account of the scattering of light by the Earth's atmosphere. So what exactly is scattering of light? So let's say this is a typical air molecule present in the Earth's atmosphere. This is called a scattering nucleus, and when light is incident on this scattering nucleus, it is first absorbed and then it is re-emitted without a change in wavelength. So this phenomenon is called scattering of light. This explains why the sky appears black in space. There is no atmosphere and there are no molecules, and hence there are no scattering nuclei. Now, let us understand why the sky appears blue and the clouds appear white. First, the white clouds. Let's say this is a congregation of water molecules present in one of the clouds. Its diameter would be somewhere around 2 millimeters, and if white light is incident on it. Now, white light is made up of several colors whose wavelengths are in the range of 4000 to 8000 angstroms. So here the diameter of the scattering nucleus is significantly greater than the wavelength of incident light. So what happens? All the colors of light are absorbed by the scattering nucleus and then they are subsequently re-emitted with equal intensity. So all the colors are scattered with equal intensity, and all of these colors are going to mix up, and hence this congregation of water molecules is going to appear white, which explains why clouds are white in color. We now understand why the sky is blue. So here's an oxygen molecule whose diameter would be somewhere around 2 angstroms, and white light is incident on this oxygen molecule. White light is composed of several different colors whose wavelengths are 4000 to 8000 angstroms. So here the situation is that the diameter of the scattering nucleus is significantly lesser than the wavelength of incident light. So what happens? Now violet, indigo and blue colors are absorbed by this nucleus and the other colors simply travel on. And since the violet, indigo and blue colors are absorbed, they are the ones to be re-emitted. So the violet, indigo and blue colors, the colors which have smaller wavelengths, are scattered more, whereas the green, yellow, orange and red, the higher wavelengths, are scattered less, and hence this molecule is going to appear blue in color. So if lambda is the wavelength of incident light and I is the intensity of scattered light, then the relationship between I and lambda is I is inversely proportional to the fourth power of lambda. Smaller the wavelength of incident light, greater is the intensity of scattered light. And when zillions of molecules scatter violet, indigo and blue light preferentially more than the other colors, the sky would appear blue, since the human eye is less sensitive to violet and indigo light. And the water beneath the sky, that will also appear blue. And since red light is scattered the least, it is used in the tail lights of vehicles and traffic signals so that it can be seen from a distance. Now, one fascinating effect of scattering is that during the time of sunrise and sunset, sunlight is intercepted by a larger number of scattering nuclei present in the lowermost part of the Earth's atmosphere. So there is an increased scattering of blue light, and only orange and red light reaches our eyes, as it is reflected by dust particles, moisture and clouds that are present in the lower atmosphere. So the next time you watch TGS Summerfest, do give a scientific thought to the dancing rays of light, along with the magnificent display of talent on the stage. Now, a summary of this video. The absorption and re-emission of light without change in wavelength is called scattering. The sky in space appears black on account of the absence of scattering nuclei. Clouds appear white since water molecules scatter all wavelengths equally. The sky appears blue because air molecules scatter blue light more than the light of other colors. Red and orange light scatter the least, making sunrises and sunset appear reddish orange. So that's all in this video. In the next video, we will introduce ourselves to the unit of mechanics in which we will learn moments.